Hi everyone, welcome to the talk. We will be talking today about evaluating multi-turn conversations, a practical guide to AI agent evals. Before we get started, raise your hand if you are building AI agents. Almost, well, more than 50% for sure. Okay, who has already built evaluations for their AI agents? I'd say 30%. And who actually trusts their evaluator scores? Okay, well, some hands. Okay, good, good start. My name is Lena. I want to share a bit of context about me. I'm an AI advisor, CEO and founder of Parse Labs. We are a conversational AI agency, have been around since 2018, and over these years we worked on more than 110 projects, and on many of them I worked hands-on myself. Good to know that I'm coming from a research background. I have 2 degrees in linguistics and in artificial intelligence, which combines really well in building chatbots, AI agents, and working in conversational AI. And I am actually quite technical. I worked as a natural language processing engineer, then I've been a full-stack Python developer, so I know how to test the traditional software. I worked as an AI engineer, and then now I'm a conversational AI advisor. And these days, I also give a lot of AI trainings for corporate AI workshops like this one, and I am in general an AI evangelist for practical human-centered AI. So why are we talking about this topic, or why I'm talking about this topic? Last year, I actually have already presented here, and I was talking about evaluating LLMs. And today, I wanted to talk about evaluating AI agents specifically. So how do we evaluate multi-turn conversations? And over the past year, I worked with medium to large organizations on their LLM setups, and we learned a lot together. And I would like to share this knowledge with you today. So let's start. What are we going to do today? We're going to talk about why is evaluating LLMs hard and the unique challenges of evaluating AI agents specifically. Then I'm going to introduce a 3-stage LLM framework updated since the last year. And I'm going to also share with you common mistakes and best practices that I saw working with teams this year. And then we will hopefully have some time for the Q&A with the goal that we all feel more confident releasing to production. So let's get started, and let's start with a quick recap about why evaluating LLMs is hard. I'm sure that most of you already know this, but just to make sure we are on the same page. LLMs are non-deterministic, and what that means is that every time you send the same response, like in this case, what are common refund policies, you get a bit of a different reply. They all kind of look similar, but the first one says common refund types, policy types, another one says common refund policies include, etc. So what hard is this is that multiple responses can be correct at the same time, and how do you evaluate if multiple things can be correct at the same time is a big challenge. Another challenge is that evaluations are very subjective, and evaluating conversations is not a very new challenge, and it's always been hard to evaluate conversations. So what does good even mean? A response can be factually correct, but still feel wrong. The vibe might be off. So that's the second challenge. Okay, so evaluating LLMs is hard, but evaluating AI agents is even harder. Why is that? We get an extra layer of complexity here. We get this multi-turn dependency, which means that same response can be correct or wrong, depending on the conversation history, depending on where it is in the conversation. So let's have a look at this example. First one, user says, I need to talk to someone. Agent says, connecting you now, one moment, fail. Fail because we actually had a functional requirement that an agent should never connect to a human agent at the first attempt. So the very first time the user asks to connect to an agent, we don't want to connect them. We want to say, please try to talk to me a little bit more, or we ask a question or stuff like that. The second example, user says, I want a refund. Sorry, I can't help you with this. Then the user says the exact same thing as in the first example. I need to talk to someone. And the agent says the exact same thing as in the first example, connecting you now, one moment. But at this example, it actually passes because we want to connect to agent after first failure. So same response can be correct depending on the conversation history. So that means that we cannot evaluate in isolation. We cannot get too much of single turn evals for AI agents. We have to evaluate together with conversation history. Then the second reason why evaluating AI agents is even harder is because one response can be wrong, but the conversation as a whole can still reach its goal and it can still be correct. So we need to decide per eval criteria what is more important, nitpicking on a specific eval criteria or evaluating the conversation goal as a whole. Okay, so now we know what are the challenges. How do we actually evaluate when many things can be correct at the same time? Let's look at an imaginary example, and let's say that we are building a customer support AI agent that has two functional requirements. It is supposed to answer FAQs, so what is your return policy and things like that, and it's supposed to connect you to a human, but not always. The first time you ask, it needs to say, sorry, please talk to me again, and the second time you try to connect to human, then it's allowed. So let's imagine we are building this AI agent and we are experimenting and we want to get a score that will tell us if we are doing better, if our new architecture is better, if our prompt is better. So let's align on what exactly we are building. We have a very simple AI agent architecture here. Let's say the user says something like, what's your refund policy? Then we have RAG, so we retrieve some context, and then we have two options. Either, depending on what the user asked, we will be calling a tool. So maybe if the user said, I want to talk to a human, then we do tool call, and then we pass that to the LLM, and it gives a response. Or we don't have the tool call, and we just do the simple FAQ search, RAG search, and we just call the LLM with the context retrieved, and then we give the output. So what can we be evaluating here? And then we do this on repeat, so it is a conversation. We do it many times. What can we be evaluating here? First, we can be evaluating RAG. So did we retrieve the right context? Then we can be also evaluating tool calls. So was it the correct tool with correct tool parameters or not? Then we can also be still evaluating the single turn. We can still do that for AI agents. So was the response good, correct, define good? And then we can do multi-turn evaluation. So did the conversation go well? Now let's go through this one by one. What can we evaluate? So first thing was RAG evals, and I won't spend too much time here because we have another talk on this tomorrow, but just super quickly. With RAG evals, we can evaluate the retrieval quality, so we compare ground truth context with retrieved context, and we calculate context precision and recall. Then we also do hallucination checks, and that's something that everyone who is working with AI agents should be doing, because that's basically the risk that you get for free if you're working with LLMs. So here we are comparing the RAG context with the LLM output, and we check, did LLM hallucinate the output or not? And for this, just for your reference, you can do two things. You can either build the hallucination check prompt yourself, or there are also libraries. DeepEval has a really nice hallucination check, and they also have another version of it using the method called gval. So have a look. What else can we do with RAG evals? We can calculate the RAGES metric. This one was already mentioned. So we can do answer relevance, faithfulness, precision, and recall, and combine it to the RAGES score. And again, there are multiple implementations of this. One is by DeepEvals, then there is from RAGES library, and then there are many more. Okay, so we can evaluate RAG, then we can also do tool call evals. And this one is also pretty straightforward, so we go through this really quickly. So here we can do tool selection accuracy, so did the agent pick the correct tool? And for this, you don't need any LLM as a judge, and surprisingly, I see a lot of teams doing that. This is actually just a programmatic check. And you can also calculate the argument extraction accuracy, so basically, did the agent pass the correct valid parameters? Then there are single turn evals, and here what we do, we define what's important for our use case and measure custom eval criteria. So we have the LLM answer, and then we ask, did it pass our custom criteria? So this probably you already know. Raise your hands if you know what LLM as a judge is. Okay, still not everyone. Well, for single turn evals, so to calculate this custom criteria, there is this method very famous called LLM as a judge. Basically, you take one LLM and you evaluate the output of another LLM on the criteria that matter to you. So we won't dig too much into it. What is important here is that custom criteria are better than generic metrics, and LLM as a judge, they help you with this, even though there are some caveats which we will discuss later. And the last thing we can do is multi-turn evals, and this is where it gets interesting. One method for evaluating multi-turn conversations is called N+1 evaluation. So what we do here is we take the conversation history, so user message 1, agent message 1, user message 2, and then we predict the agent response, and we evaluate the agent response given the conversation history. So we take n turns of the conversation and evaluate the next turn. How does it look like if we talk on the test set level? So instead of having just a single string in the column A, we now have the whole conversation history, and here it is a good idea to add different variability and try different lengths of conversation history, and then have different LLM as a judge per conversation history. So this is the example that we already looked at. If the user said, I want to talk to a human, then we return pass if the agent requested to tell about the issue in more details, otherwise we return fail. And the next test scenario is the user says, I'd like a refund. Agent says, sorry, I can't help with this. User says, I want to talk to a human. And here we return pass if the agent connected to a human. Otherwise, we return fail. So again, the same user message gets different pass or fail criteria depending on the conversation history. So how does this process look like? We get these test cases, which I just showed you. Then we predict the next step. So the agent says, sure thing, let me connect you to the human. Then we pass this to our LLM as a judge. We get a score, and then we check if the judge response was correct. Well, we went through this already, so we'll skip this. When and why do we use this N+1 evaluation? It helps us to capture quality of the contextual instructions, which you can't do with single turn evals. I often work with companies that have long instructions in the prompt that first, let's say it's a customer support use case, and first the agent needs to introduce themselves, then they need to ask the user for their name, then they need to do this, then they need to do that. You can only test this in context with N+1 evals. You cannot do that with single turn. And another one is N+1 evals help you with robustness of your replies. So if you add different conversation history and then you test against it, you will get scores that you can actually trust. Now, the next method for multi-turn evaluations is simulations. This is a very simple idea that you take one LLM and you make your agent talk to this LLM, and then they have the conversation, they role play it, and then you get the conversation transcript, which you can evaluate against the metrics that you defined before. So on this example, we just have the single simulator prompt. So you are role-playing as a customer with the following profile, and then you describe the backstory, the persona, the goal. Maybe you add some examples of the conversation that this user persona can have, and you run it, and then you get this transcript. And then what you do afterwards is you auto-score it. This is the same technique that customer support teams have been using for a very long time, where basically you define a lot of criteria and then you score the whole conversation against this. So maybe you have the criteria number 1, did the agent introduce themselves, then did the agent collect the prospect's name, etc. And when do we use that? I typically use this technique with simulations during the experimentation stage, when I don't want to manually test the scenarios that I already know have been failing. So what I would do is I would run the simulations after the prompt update. I would read the transcripts. I would automatically score them as well to get the metric and see if I'm moving closer to my goal. Now that we know what can we be evaluating, let's put this together in the LLM eval framework. I split the LLM framework into 3 stages. First is experimentation stage. This is when you are trying to improve your prompt and your agent architecture and see if it passes your test cases. The second one is live monitoring. So this is when you already go to production, your agent is already live, and you want to see how that is doing. And the third one is post-production evaluation. So this is after the conversation has already happened, and you want to analyze, did you do well, and what to do next. So let's go through this one by one a little bit. The experimentation stage, what you do is you define what good looks like, and you create the evaluators. After that, you need to do alignment of LLM as a judge labels on human labels. We'll talk about this now. Then you experiment with this until it passes your tests, and then you are ready to run regression tests before the release. So then you release, you need to log the data, and then you need to set up the real-time alerts to get notified about any failures so you can fix them really quickly. And then on the post-production, you review the logs, you see what went wrong, you update your test sets, your evaluators, and you track business metrics. Let's go through this one by one. So the experiment stage first. The experiment stage helps you answer two questions. One, how do I know if my new prompt is better than the old one? And two, can I safely release to production? And during the experiment stage, actually, you have to create two test sets, and this is something that I see a lot of teams are missing. One, you need the test set for evaluating your evaluators. It needs to be human labeled, and you use it to calibrate your judge to make sure that you can trust the score. And two, the test set for evaluating your agents. And this one is used to test your AI agent using the evaluators that you already trust because they're aligned on the human labels. So how does this process work? Step number one, classic step, we define what good is, and then we create evaluators. Actually, this is one of the hardest part. It's very hard to say what matters to you and define those metrics. But what you need to do is to sit down, do the brainstorming, and define what is important for you to measure for your use case. And this typically includes the happy paths, so business critical queries, then unhappy paths, edge cases, out-of-domain questions, and then it also has the adversarial test set, so testing against prompt injections, jailbreaking attacks, and stuff like that. So you define what good is, then you write your LLM as a judge evaluators. In this case, let's say we have two. We have one for the FAQs, which is checking whether the agent is answering based on the context and is not hallucinating. And another one is connect to human. So this one returns pass if agent asks the user to share more about their situation before connecting to human. Good, we defined our evaluators. Can we actually trust them? No, not yet. What we do first is we build an eval alignment test set, a step that's often missed. Let's have a look at what happens here. We have the user message, so all the test cases. Then for some of them, we have context returned by RAG. Then we already write down the LLM output, the metric name, so we know which evaluator we are evaluating. And then we take a human, a real one, not AI that labels this test set, a real human who sits down and labels those cases and writes the explanation. Why do we do that? Because if you use AI to label your eval alignment test set and then you check if your agents are aligned, you align AI on AI and you get something that is overfitting. This is not how that works. So this is step number one. And step number two, when you already asked your humans to label your alignment test set, then you apply your judge on this LLM output. So you get the response from the judge, so column G, the judge label. Then you compare your judge label with a human label. And then you basically give it an alignment score. Is your LLM judge in alignment with a human? If not, what do? You go back, you improve your prompt, maybe you look into your test cases until this is in alignment. And once it's in alignment, then congratulations, you can now use your judge for evaluations. Okay, so let's say we now feel like we can trust our LLM judges. Now we move to the next step, which is experiment. And here we need to create the test set for evaluating. Then we also need to test manually. Then we implement the methods that I already discussed. So we run simulations, we run n+1 tests until the score passes the threshold. And then you update and realign your judges, adding new functional requirements until you pass the tests. And once you are happy with your experiments, once your team is happy with the experiments, then we go to step 3, the release gate. And here we run regression tests once again just before the release to production. Then we run adversarial test sets before the release. And we don't touch the production until those pass your threshold. Cool, so our agent is live. We are happy with this. Now it's in production and we need to do live monitoring. Here there are two steps. One we already mentioned in the previous talk. The first one is observability layer. You cannot manage what you don't measure, so you need to log everything in the trace. So you definitely need to log the prompt version. Full conversation tools called RAG, context, tokens, latency, user feedback, errors, all of this needs to be logged so you can later track what went wrong. And another thing that you can also log asynchronously for AI agents specifically is things like I don't know responses or human escalations, because they give you signals on something that went wrong so that later you can see, okay, maybe this is the use case that I want to add to my test set, and then improve the prompt, and then improve the knowledge base, etc. So here, there are lots of different platforms that you can use. For example, LangFuse, that was already mentioned, has a really nice observability platform. Now, step number 2, real-time failure alerts. So here, the idea is that as the agent is running in production, you want to capture the failure modes really quickly. So the way you can do it is you can flag dangerous cases and immediately send them as Slack alerts to your team so they can pick them up, and you will be tracking outlier signals like if the conversation was too long, or if the latency skyrocketed, or the cost for this conversation for some reason was longer than average. Then you would be looking into tool looping or negative sentiment, or if the safety guardrail was triggered, technical failures, hallucinations, and emergency and safety detection. So all of this you get alerts for, and also it's a good idea to do a super simple uptime ping test to make sure that you are not the last one to find out that your agent is actually no longer working. Great, so we already had the conversation, our AI already had the conversation, so now we need to do the post-production evaluation. Here, what do? We have the review loop. So once a day, you auto-score conversations using calibrated judges, and here the idea is for you to surface out of all of the conversations that your agent had where it went wrong. So you would be looking for indirect signals like repeated I don't know responses, human escalation requests, maybe negative sentiment, unusually long conversations, so all of those things. And then you pass those flagged conversations to the annotation queue so that real humans, reviewers, can manually once a week review some random subset of those flagged conversations to see if they pass or fail, and comment for the prompt engineers if maybe we need to add a new functional requirement into our AI agent and push back those examples to the test set. So during this review loop, we are actually sourcing the examples for our test set from the production logs so that our test set is as realistic as possible. And then after that, you pass all those comments from human reviewers to developers so they can review their test cases, fix the prompt, update the judges, run tests, and then run the regression tests and safely release to production, and then it goes all over again. So here are important 2 options here. How we make decisions. If you discover an example and the judge already exists, but for some reason your agent is failing, it means that you need to add a new test case to existing LLM as a judge test suite and keep updating your main prompt until it passes the tests. But it can also happen that there are some examples that were failing, but they never even were part of your evaluation test set. So in this case, you need to add a new LLM as a judge and then go all over for the LLM as a judge evaluation alignment process until your agent LLM as a judge is aligned on human labels, and you can use this for your further testing. And step number 2 here is business KPIs, so defining success as a business metric. Here, the idea is that you want to measure the quality and task completion of the conversation as a whole, and you want to be measuring things like task completion rate. So depending on your use case, it can be how many bookings were confirmed, or refunds issued, or questions resolved. So the business metrics instead of the conversation metrics. You might be measuring human in the loop, user sentiment, and domain-specific KPIs. And here the idea is that a perfect conversation is the one that reaches the end goal. I actually don't believe that there are perfect conversations, and we should also not be trying to reach this goal because it's just unattainable. And those business KPI metrics, so defining what the goal is, help us stay focused on what actually matters. And now I wanted to wrap up with some best practices and some mistakes that I commonly see in teams this year. So tip number 1 is balancing your test sets. And maybe if you are a machine learning engineer, you think this is quite obvious. And I work a lot with software engineers for whom this was not obvious. So I'm going to repeat this again. The test set needs to be balanced. That means that the amount of test cases that you have per LLM as a judge needs to be on average the same, or you need to come up with a weighted metric. Because if you don't do that, here is what happens. You have 3 LLM as judges, and one has 50 test cases, and another 2 have 5 each. So if all 50 from one LLM as a judge pass and all 10 fail, you get 80% score, and you feel super happy that, okay, your agent is performing really well, but actually 2 of your LLM judges failed, and maybe they were the most important ones, so are you even optimizing for the wrong metric? This is one of the common reasons why you don't trust your evals. Tip number 2, test on production examples and not synthetic. One thing that I see very often is this idea that, okay, why don't I just generate the evaluation test set, evaluation examples, I'm going to save myself a lot of time. And what happens then is that you are overfitting on imaginary examples that LLMs came up with, which have nothing to do with the real production examples. And as a result, you cannot trust your scores. So synthetic data might feel like a productivity shortcut, but actually it is not. And my suggestion here is, okay, maybe when you are starting, well, first my suggestion is always to talk to domain experts and ask them to come up with a test set. If you had some previous emails or call transcripts or somewhere else where you can source those examples, that's great, use that. If that's not possible, okay, for the very first run, you can use the synthetic examples and come up with them. But then as soon as you release to production and as soon as you start getting the production conversation logs, the idea is that your test set needs to contain the production examples, not the AI-generated examples. Tip number 3, prioritize judges ruthlessly. Another thing that I see very often is that people come up with tons of LLM judges and they don't know which one is more important, and some of them, they don't even remember what it means. And basically you get a huge table with a lot of metrics and you don't know are you actually doing well or not. So my suggestion here is to only measure what matters and to choose your battles and not try to be nitpicking on those conversation quality, smaller kind of eval metrics. Instead, pick the ones that really matter and then focus on evaluating the conversation goal and measuring the conversation quality as a whole. Because if you have too many evals, it's not only that you don't trust them, it's also slow and expensive to run, and during the experimentation stage you want to move fast, and this leads to you not trusting any of them. Tip number 4 is aligning your judge before using it. So this we already talked about, and here I just wanted to emphasize and mention some things that teams still do wrong. So every judge needs to get its own alignment test, and every time that you get a new judge metric, then you need to do the alignment process again. And every time any functional requirement appears again, you need to do this alignment process again. And it's a good idea to run those judge tests at least multiple times, because LLM as a judge, they are also non-deterministic, just like the software that you are trying to test. And every time they can give you a bit of a different response. And by running it multiple times and taking an average, you reduce this risk a little bit. And on this topic as well, checking prompt leakage. One thing that I often see, especially if you are using Claude or AI to write your prompts or create your test sets, which I imagine a lot of you are doing, what LLMs would be doing is they create you LLM as a judge prompt, and then they create the test set, and surprise, it turns out that the same examples from the test set are also in your LLM as a judge prompt. So what are we doing then? LLM as a judge should not have examples from the test set, and you need to clean up your prompt until it doesn't have those examples. Otherwise, you cannot use them. So what we do is we have some small Python script or Claude skill for checking. So every time you update the prompt or every time you add the new eval test case, there is the risk that something will leak. So you run this, and then you check, are there any leaked phrases? In this case, yes, I had the phrase which said refunds are processed within 5 to 7 days, and probably it was given as an example in my LLM as a judge, and I was also evaluating on this, so please fix that. Then tip number 6, and the last one, is test-driven development, and it's the most important one as well. So the idea here is to update your test set before touching the prompt, not the other way around. So one thing that I often see is this urge to go and fix something in the prompt and then fix again, and then you test manually and then you fix again. And then it turns out that you already added a bunch of functional requirements into your prompt, but your LLM eval metrics, they actually do not reflect that. And then you go again into the problem that you don't trust your evals and you don't have again the metric to tell you if you are doing better or not. So this is quite a hard discipline exercise, but I really suggest that you first, when you identify the failed cases, you first go and update your evals and LLM SJIs and go through the LLM alignment process, and only then you update your prompt, your system architecture, your RAG setup, or anything else you are currently testing. And then you repeat. So this is something that happens continuously, and the eval test set is also something that continuously grows as you introduce new functional requirements, as you get more users, as you get to see more edge cases. So here the tip is to focus on optimizing test coverage instead of prompt quality as the first thing. So just a recap of the final framework. So we have 3 stages. We have experimentation stage, live monitoring, and post-production. During experimentation, we define what good is, we create evaluators, then we align those evaluators on human labels, then we experiment until we are happy with the results, then we run regression tests, then we can release to production. During live monitoring, we log all the data, all the traces, so we can later debug what went wrong. And we also set up real-time alerts for any critical production failures. And during post-production evaluation stage, we analyze the logs, and we do this both manually and automatically. We find fail cases so we can update our test set and LLM as a judge, and we track business metrics. Some small tip for you here, LLM eval library. So all of those things that I talked about just now, they are quite high level, and you can use any kind of platform or tool to implement those metrics. There are plenty of them, and I have put together an LLM eval library in Notion, where there are a lot of different tool providers. Also, many of them are open source, so if you are looking for the providers for your LLM eval setup, so maybe you can get some inspiration there. So that's it for today. Just to sum up, key 3 takeaways that I want to take you with you today. 1, for AI agent evaluation, use multi-turn evals among other evals. Number 2, always align your judges on human labels first before trusting your eval to evaluate on your test set. And 3, test-driven development always. First, update your test set and the judges, and only then update your prompt. Here is my LinkedIn. I write a lot about LLM evals, Gen AI, and everything that we do in our agency. So feel free to stay up to date, and thank you.